Hi everybody. Today what we're going to go through is using cofactor expansion to determine the determinant of a 4x4 matrix. So we're going to be working through with this one. So with our matrix here, when we use cofactor expansion, we can pick any row or any column that's a straight line without any zigzagging, probably not any diagonals. And what we're going to do is the determinant is equal to the sum of the cofactors of your selected row or column. And what we're going to do is we're going to pick the row or column with the most zeros. So we have to calculate less cofactors when we do this. So if we have a look, I notice that column number 4 has 3 zeros in it. So three of the cofactors will cancel out, and I'll be left with only calculating one cofactor. So what this looks like, so we're going to call this matrix A. So the determinant of matrix A is going to be equal to 3 times the cofactor for that spot on our matrix. So that will be, this is in row 2, column 4. So obviously we know what 3 means, but what does cofactor of 2, 4 mean? So to calculate the cofactor 2, 4, we will have to, this is equal to -1 to the power of the sum of the indices. So the indices, so let's say we have I and j. The first part of the cofactor will be, actually, so if we have a spot in our matrix at I and j, its cofactor will be the cofactor at I and j. So what that would equal is -1 to the power of I plus j. Okay? So here I is 2 and j is 4. So we have we have -1 raised to 2 plus 4. This gives us an even exponent and will evaluate to a positive sign. The second part of our cofactor is the minor of this matrix at row 2, column 4. What that gives us is the determinant of the rest of the matrix if we get rid of the column we picked, and at the spot at the we'll also be canceling this row. So what this means is we will be taking the determinant of what's left in the matrix. So notice we have 3 rows and 3 columns left in our matrix. So the minor will be a 3 by 3 matrix, which will be -1, 0, 1, this row, and then the second row will be this row because we got rid of all the other, we got rid of the second row. So the second row of our minor will be this one, so 4, 0, 1, and our third row will be the final one in here. So now we need to kind of go back to the drawing board and do this all over again on this 3 by 3 matrix because we don't have an algorithm to work with like we do for a 2 by 2 matrix. So what we're going to do is we will do this process all over again, and we will pick the row or column, the straight row or column with the most zeros in it, which will be this one. So the determinant, okay, so this will evaluate, so we're going to carry the 303 down to the next line. We will have -2 times the cofactor, I can't use C again. We'll go C prime of, this is row 3, column 2. So this will equal, we're going to carry that over again. We have -2, oops. And then we have -1 raised to the sum of the indices here. So 3 plus 2 is 5, which is an odd number. So we will have an odd, the -1 will be odd, and that will cancel with the -2 over here in a moment. So now we can take the determinant of, that is multiplied by the determinant of the remaining matrix once we cross out this row, because we are taking the cofactor and the minor at this spot. So we ignore everything. We ignore the row it's in and the column it's in. So we are left by taking the determinant of -1, 1, 4, 1. Notice that I'm using straight bars. Straight bars means determinant of whatever's inside. So matrices, like originally, can be curved brackets or boxy brackets. And if I call this matrix B, the determinant of B can also be written as straight bars A, B, C, D. Okay? That might come up later. So, I noticed that I have a algorithm to find the determinant of a 2 by 2 matrix, which is, so the determinant of a 2 by 2 matrix would be the top left times the bottom right minus the top right times the bottom left. So we're going to evaluate these numbers. We have 3 times -2 times -1, which gives us 6, and we're going to multiply that by the determinant of this over here. So this gives us the top left. We have the top left. Hang on, where's the laser? Okay, we have the top left and the bottom right multiplied together. That gives us -1. Oh, sorry, that's a rookie move right there. So we have -1, and we're going to subtract the product of the bottom left and the top right. So 1 times 4 is 4. So this gives us 4, obviously. So there we have 6. Sorry, we have 6 times -5. This gives us a determinant of -30. And that is all for the determinant of this matrix. So one thing to remember is that we are just trying to find the row or the column with the most zeros. You're going to pick it and then perform cofactor expansion on that row or column. So I hope that helps, and good luck with your work.